It's 2 in the morning. You check your phone. The screen tells you it's dark outside, and somewhere deep in your chest, a switch flips. Your body starts winding down, even in a lit room. You didn't choose that. Your eyes never even saw the sun set. Somehow, you still knew. Now, picture a different room. Steel walls, no windows. 300 meters of black ocean pressing down from every direction. Inside, a young sailor is standing watch, staring at a sonar screen that has looked exactly the same for 6 hours. The clock on the wall says 0300, but there is no night here. There never was. And that's where this gets strange. Because a nuclear submarine doesn't run on day and night, it runs on something else entirely, something built by naval engineers who assumed the human body could be reprogrammed like a piece of equipment. For decades, most submarine crews didn't work in 24-hour cycles at all. They worked in 18-hour ones. 6 hours on watch, 12 hours off. Repeat. A crew member's entire existence compressed into a day that doesn't exist anywhere in nature. Why 18 hours? Because it divides evenly into 3 shifts, and 3 shifts means every job on the boat stays covered around the clock forever without gaps. It's elegant on paper. It solves a scheduling problem perfectly. There's just one flaw. Nobody asked the human brain if it agreed. In the late 1970s, a researcher named Paul Naito studied crews living under this exact system aboard a nuclear submarine. He tracked their body temperature, their mood, their alertness, all the invisible rhythms that quietly govern how a person feels and functions. What he found was unsettling. The sailors' internal rhythms didn't reset to 18 hours. They didn't fully sync to 24 hours either. Instead, their bodies fractured into something in between, a kind of biological static, superimposing 2 competing clocks that never resolved into one. Mood dropped. Alertness became unpredictable. Some men functioned fine at hour 2 of a watch and were barely present by hour 5, and the drop-off didn't line up with anything on the actual clock. Here's the part almost nobody talks about. Melatonin, the hormone your brain releases to tell you it's time to sleep, doesn't care what schedule the Navy assigns you. In a study of crew members aboard a Trident submarine, researchers measured melatonin release across a full deployment. The submariners were locked into an 8-hour day, watch after watch, week after week. Their melatonin rhythm never adjusted, not once. It kept quietly running on a cycle close to 24 hours, completely out of step with the world the sailors were actually living in. Their bodies were trying to keep a kind of time that the outside environment had made irrelevant. Their brains, in a very real sense, still believed in a sun they hadn't seen in months. Think about what that means. You could go to bed, by the clock, at what your chart calls night, and your own hormones might insist it's the middle of your afternoon. Some men described feeling wide awake precisely when they were ordered to sleep and dazed with exhaustion exactly when they were ordered to perform. The boat didn't care. The watch bill didn't care. Somewhere below the waterline, 100 human bodies were quietly rebelling against a calendar the Navy invented. Some navies eventually noticed. On more recent long missions, like French ballistic-missile submarines running 70-day deployments in total isolation, researchers switched some crews to a more human-friendly rotation, splitting sleep into 2 blocks across an actual 4-hour day instead of forcing in 8-hour compression. And something interesting happened. Cortisol, the hormone tied to stress and alertness, adapted almost immediately to the new work-rest pattern. It shifted right along with the shifts, cooperative, obedient, but melatonin still refused. Even with a smarter schedule, even with better lighting, the sleep hormone kept drifting on its own private rhythm, barely touched by anything the crew or the boat did. 2 hormones, controlled by the same brain, living by two different clocks, inside the same silent body, hundreds of feet underwater. So why does this matter beyond a curious footnote in a physiology journal? Because these aren't factory workers on a night shift who can step outside on a break and let the sun correct them. Submarine crews get almost none of that. The lighting on most boats is far dimmer than daylight, roughly the brightness of a shopping mall, never bright enough to reset a human circadian clock. No windows, no sunrise, no accidental glance at the sky that quietly recalibrates the brain the way it does for the rest of us, without our even noticing. The only cues left are artificial ones: a clock, a watch schedule, announcements over a speaker. Everything that normally keeps your body in sync with the planet has simply been switched off. One researcher who studied these effects, Martin Moore-Eade, put it in a way that's hard to forget. He pointed out that these are the very men whose hands sit closest to the most consequential decisions a military can make, men managing nuclear propulsion systems and on ballistic-missile submarines, weapons capable of almost unimaginable destruction. And their alertness was being shaped by a schedule that fought their own biology every single day. Not because anyone was careless, because nobody had fully understood, when the schedule was written decades earlier, that the human body doesn't simply obey a clock. It negotiates with it. Sometimes it refuses outright. And the sleep itself is stranger than people expect. On these compressed watch cycles, crew members don't get one clean block of rest the way you probably do tonight. Sleep studies aboard submarines found a biphasic pattern, one longer sleep period and one noticeably shorter one, split unevenly across each cycle, with different quality and different efficiency in each. Picture trying to survive on a long nap and a short nap instead of one continuous night, week after week, for a deployment that can stretch past 2 months. No sunlight to anchor it, no weekend to catch up. Just a hum of the reactor and a clock that means less than it should. There's a smaller, stranger detail hidden in all of this too. Many submarines use what's often called hot bunking, where there simply aren't enough beds for every sailor to have their own. A crew member finishes a watch, walks to a rack that's still warm from the body of whoever just left it, and climbs into sleep in sheets someone else was using minutes earlier. Your bed isn't yours. It's a resource, shared in shifts, passed from one exhausted body to the next, following the same relentless rotation as everything else on the boat. And then there's the color of night itself. On the surface, darkness just happens. Down here, it has to be manufactured, and the Navy manufactures it in red. When a boat needs its crew alert for a night watch, or when someone has to use the periscope to scan a genuinely dark ocean above, the lighting in certain compartments shifts to a deep red glow, not for atmosphere. Human eyes are far less sensitive to long red wavelengths, so red light lets a sailor's pupils stay adjusted to darkness while still reading a dial or a gauge. It's a workaround for a problem that shouldn't exist a few hundred feet underwater in the first place. A trick of physics standing in for a sunset nobody on board will see. Even the fixes being tested today reveal how deep the problem runs. Researchers at the Naval Submarine Medical Research Laboratory have spent recent years asking a question that sounds almost embarrassingly basic. What if the lighting itself was the medicine? A psychologist there named Sarah Chabal has helped study whether carefully timed blue light delivered to individual crew members at the start of their watch can nudge a submariner's internal clock back towards something resembling normal, essentially simulating a sunrise for a person who hasn't seen one in weeks. Early attempts at just brightening a submarine's general lighting didn't move the needle much. The newer approach is stranger and more personal, tuning each sailor's light exposure to their own body. Because on a boat where the watches never stop, there is no single sunrise that works for everyone at once. Some crews have even tested moving away from the old one, 8-hour watch entirely, running trial deployments on a full 2-4 hour schedule instead, chasing a simple, almost obvious idea that took the Navy the better part of a century to seriously test, match the schedule to the brain, instead of asking the brain to match the schedule. So what does a submarine crew actually do at night? The honest answer is that they don't. Not in the way you mean it. There's no night on a submarine, only a clock insisting there is one, and 100 human bodies quietly disagreeing with it in ways that hormone tests can measure, but no one on board can consciously feel. Somewhere in that boat, right now, someone's melatonin is rising on a rhythm nobody assigned them, whispering that it's time to sleep, while a watch bill built by engineers decades ago insists it's time to work. And they get up anyway. They do the job anyway. Their biology loses the argument every single time, and it never stops making it. There's one more layer to this that rarely makes it into any documentary. Scientists studying submarine crews classify the boat itself as what they call an ice environment, short for isolated, confined, and extreme, the same broad category researchers use for describing life on a long-duration space mission. A submarine and a spacecraft, on paper, have almost nothing in common. One floats in ocean water, the other floats in vacuum. Yet, physiologically, the two environments do something eerily similar to the people inside them. No natural light, no open horizon, recycled air shared constantly by the same small group of people for months at a time. In a study following 122 crew members through a 101-day submergence, researchers found measurable changes in health markers stretched across the entire deployment, evidence that the body doesn't just tolerate this kind of environment quietly. It registers it, tracks it, responds to it, the same way it would register any other prolonged stressor, even when the sailor on watch feels perfectly fine and reports nothing unusual at all. So the days blur in a very literal, physiological sense. Meals become one of the only remaining social cues that separate one day from the next, since there's no dawn to mark a fresh start and no dusk to close one out. Ask a submariner a week into deployment what day it is, and many will genuinely have to check, not because they're careless, because the one instrument every human being has relied on to answer that question for the entire span of our evolutionary history, sunlight moving across a sky, has been engineered out of their world entirely, replaced by a clock on a bulkhead that the body itself never fully agrees to obey. Tonight, when you glance at a dark window and feel that familiar pull towards sleep, remember that somewhere below the surface of the ocean, someone is fighting a version of that same pull with no window, no sunset, and no way to win.